Hi, I'm Jake, the creator of Luminary. In this video, I'm going to do a quick overview and demo of the tool. Luminary is an AI workflow tool. It's a desktop tool that you can download for Mac, Windows, and Linux. It's available for free, and it is open source. It's useful to people who want to create complex AI behavior, making multiple AI bots work together. The platform is meant to be developer friendly. You can bring your own code and easily share profiles with others, so developers can create and test workflows and then pass those workflows to users. Workflows can achieve all sorts of tasks, everything from generating content to helping start businesses and more. So why use Luminary? Have you ever tried to train an AI on complex tasks like starting businesses, building websites, or generating lots of media automatically? It's not easy. Trying to train a single ChatGPT bot on an entire task can often lead to hallucinations and produce inconsistent results. So what Luminary does is allows you to make AI bots work together. What you want to do is break down something complex into smaller parts, and then train multiple AI bots on those simpler tasks and link them together. The results are often much more consistent. Here's a few ideas of what could be done with Luminary. You could create a workflow to set up a merch store automatically by prompting about a merch brand, generating images, sending those images to something like Teespring, generating products, SEO, marketing data, and then finally publishing the store. You could also set up a workflow to create AI music and automatically publish that to Spotify, Apple Music, and other places. Luminary is also useful for developers who want to use AI workflows in their own applications, such as for data migration, generating objects for their own users, etc. Let's take a detailed look at a simple example of a video generation workflow. In this example, we will generate outlines first by prompting the AI. I want to make a YouTube short series about the world's tallest buildings. I want 3 videos, each 1 minute long, and I want them to be exciting and informative. Our outline generator assistant will generate the outlines and send them to the movie script generator. The movie script generator will create a new script for the video. The new script will include a narrator as well as stage instructions describing what to show on the screen. Finally, that script will be passed to the video generator, who will create a request for the Pictory Video API. That external API service will then send us a link to the video it created, and Luminary will download that video automatically to prepare to upload it to YouTube. So let's take a look at what that example looks like in Luminary itself. This is the graph of the workflow that we just took a look at. We can see that our outline generator is outputting a script outline, and that's being passed into our script creator, which is then outputting a script and is being passed to the video creator. Now let's go ahead and run this workflow to show you what it looks like. We'll click on Execute at the top. Within the Execute menu, we can see the Chat tab, and within that, we can see the sidebar, which has the 3 assistants that we just took a look at. If we click on the bulk outline generator, click New Thread, and paste in our prompt, we can hit Send. Here we see the AI is responding, and now it's going to go ahead and generate the script outline objects. On the right side, we can see these objects being populated in the object tree. And now those script outlines have been handed to the script generator, who has created script objects for us. Those script objects will then be passed to our video generator. It will take a moment for the video to render, so we'll just wait a second. Almost done. The messages that you see showing here are system messages. These are created by Luminary itself and also by any scripts that you run. I'm running the Pictory script right now, and it is outputting information telling me what the script is doing while it's running. And now it looks like the Pictory render has finished, and we are downloading the video and thumbnail from that video, and now we can see the video on the right side in our object sidebar. So if I go ahead and click on that, so we have a little preview window here, and I can also click on the link and it'll open up the video.
Shrouded in the clouds, the Shanghai Tower twists towards the heavens.
And so that's the video that we just created. We also got a thumbnail here. Then it downloaded, and then we can see the raw information of the object that was outputted. So this was a quick example of a video workflow running in Luminary. Let's take a look at how we build workflows in Luminary. So how does Luminary work, and how do we set up workflows? There's three main parts to Luminary: objects, assistants, and graphs. The first part, objects, allows you to define the data that will be passed between assistants. By defining object schemas, Luminary makes it easy to pass these objects around. For instance, if we wanted to create a video workflow that generated videos, to do that consistently, we might want to first generate script outlines, and then movie scripts, and then eventually videos themselves. To generate a video, we might need to break that generation process into multiple parts so that we can interface with whatever video generation service we are using. Luminary makes this all possible by allowing us to create multiple different objects, defining what those objects do and mean, and then informing the AI of these objects and allowing multiple AIs to work together by passing these objects between them. So let's take a look at how object schemas are created in Luminary. In the Build menu, I have an Objects tab, and here I have a list of all the object schemas I've created. A good example would be the Pictory request. If I edit this, I can see that it has 7 different fields. Each field has a type and a description and a name. We can also insert validation rules for a field. We support many different types, including strings, numbers, objects, and even arrays. Using this UI, you can easily create any sort of schema that you need. You can also hit import from JSON example, and you can paste a JSON object here, and it will convert it to a schema based on the example object you give it. The second part is AI assistants. Luminary allows us to create these agents in the app, defining each assistant and its particular job. We can assign the object schemas we created earlier as assistant inputs and outputs. This allows us to define what information assistants will be taking in and passing out. We can define different functions for our AI assistants to perform actions for us by executing terminal commands. This means that we can link and execute any code that we wish. Luminary also assists in automating the communication between assistants so that if you do not want to bring your own code, the assistants will still pass objects between each other seamlessly. To give you a better idea of how agents perform in these workflows, let's take a look at an example. As with earlier, if we want to generate videos, we would use 3 different assistants: an outline generator, a script generator, a video generator, and then those 3 assistants would then pass their inputs and outputs between each other and finalize a video to be uploaded to YouTube. Now let's take a look at how to build assistants in Luminary. Under the Build menu, I can click the Assistants tab, and I'll be shown a list of assistants I have. Luminary currently supports assistants from OpenAI. So when I edit or create an assistant, I am greeted by familiar fields: name, description, model, response format, temperature, and top P. These are all fields that are defined by OpenAI for their assistance feature. Creating an assistant in Luminary will save the assistant to your OpenAI account. Luminary also tracks a few things that OpenAI does not, such as what input schemas and output schemas should be attached to this assistant, as well as advanced information about each function. Functions can be defined the same way as OpenAI assistants require, providing a definition to the AI to tell it how to call the function. However, this does not provide any code or functionality to the AI or OpenAI until we connect the code that you want to run to Luminary. To do that, we have an implementation section where we can input commands such as node and then browse for a particular script to run. We can also define environment variables as well, and a working directory and timeout. Another important part to creating an assistant is providing instructions for the AI. Luminary breaks down providing instructions to the AI in three main parts. Identity and business logic. This is where you tell the assistant who it is and what its purpose is. Then the processing steps, where you outline specific steps and workflows that the assistant should follow. And then finally, functions and output instructions. This is where you describe the functions that you provided and any special instructions the AI might need to know. These are all instructions that users can input and control. We also have system instructions that Luminary generates on its own. Depending on your configuration of the assistant, Luminary will generate multiple different system instructions. Finally, we can click on the Preview tab, which will allow us to see the entire instruction set passed to the OpenAI assistant. This includes input and output schemas, as well as other things that Luminary inserts into the system instructions. The final part is graphing the workflow. Now that we have our assistants and we've defined input and output objects, we have what we need to connect this all together. Graphing the workflow consists of connecting multiple nodes together. Each node is an assistant, and it lists multiple inputs and outputs on either side. These inputs and outputs are the object schemas that we created earlier. In our video example, we can see that we connect our outline generator to our script creator, to our video creator, and then to our upload to YouTube function. The upload to YouTube function is an example of a standalone function. Sometimes a workflow needs to perform an action without AI involved. Standalone functions allow execution of any code or script that you wish. Let's take a quick look at the graph editor in Luminary. Under the build menu, I can click on the graph tab, and here I can see the graph editor. Every assistant becomes its own node. You can drag an assistant from the assistant library and drop it onto the canvas. You can connect the inputs and outputs of each node to another node, and nodes can output to multiple nodes at one time if needed. The graph editor also allows us to set up standalone functions as well. These functions do not require AI interactivity, but just run the function with whatever they are passed as input. Upload to YouTube is a good example. We can drag upload to YouTube and then send a video to that function for it to upload. Let's now quickly take a look at the scheduling feature in Luminary. I can press the execute button and then go to the schedule tab. This will show me a calendar where I can schedule my different workflows. I can click on a future date, and I can name my event such as post video, and then I can select an assistant. The idea is that we can select an assistant and pass either a message or an object to it. This allows us to generate objects today and then schedule those generated objects to be passed to other assistants in the workflow later on. For example, if I wanted to create outlines and scripts today for 10 videos, I could then generate those videos later or perhaps upload them to YouTube next week. I can search for existing objects that I have, select them, and that object will then be sent to the selected assistant. I can also select recurring events and make this a pattern of daily, weekly, bi-weekly, or monthly. I can say it's weekly, and I can make it last all month. If I hit save, we will see that all of my events have been created, and each of them have a yellow dot, which says that they are pending. The dot will become green when it has been ran. Luminary provides a profile system that allows you to save and share AI workflows easily. Everything is saved in a zip file, which you can then share and import. This makes Luminary useful to both developers and users. Developers can take advantage of Luminary's Build tab and link in their own code and services, then share their workflow with their customers and community. Those users can then use this same tool to import profiles and easily interact with the AI assistants. Luminary provides its engine as a portable NPM library called Luminary Engine. Users can design and test their own workflows using the Luminary desktop tool. Then workflows can be exported via the zip format and then imported into the Luminary engine. This allows developers to use their workflows in their own applications. At the moment, the Luminary engine supports Node.js. Other platforms could be added in the future with community assistance. Luminary was proudly built with Windsurf. It's an AI IDE. Personally, I've been developing for over 20 years, and this tool has allowed me to get a lot of work done in times when I don't have a lot of energy to code myself. Windsurf was able to make most of the app that you see here within about 2.5 to 3 weeks. Luminary is open source. I'm open to contributions, and it's covered under the MIT license, so you can use it for whatever you want. Thank you for watching. Please like this video, subscribe on YouTube for more projects. If you could star Luminary on GitHub to support the project, I would appreciate it. And see you guys on Discord.